This is a 3D graph, as opposed to like our normal two-dimensional XY coordinate plane, Cartesian plane. This is how you do a 3D. Are you guys saying we did not do this last year?
I think we talked about it.
Maybe one day we did it? I don't know. Okay, it doesn't matter. So on the normal graph, this is the x axis and this is the y axis. So what this is supposed to look like is like the corner of a room, basically. And also, they could go down and back. These would be like the negative coordinates. Okay, so it could look more like this. But, you know, if I just drew that, it might, anyway, it might look more confusing. So you can't have negative coordinates on these, but if you take off those dotted lines, there are no negatives. Okay, so this line that's supposed to be coming towards us, kind of, is the x-axis. What the heck? This line going out to the right is the y-axis. And guess what this guy is going straight up? Z-axis. Okay, so I wish they would have done like X, Y, Z, because that probably would have been more like this one, but they didn't. So the one coming towards us is the x-axis. And when you write coordinates for a point, it's going to have three coordinates. An x-coordinate, a y-coordinate, and a z-coordinate. It's kind of hard to show points. Like, that's why they drew a box on some of these, to show, like, if I just draw a point, like, floating in space, you can't really tell, like, from your perspective, if that's, like, supposed to be near or far away from you, or, like, the depth. So that's why they drew a box here. So, let's start with this. If I go on the x-axis and put a point, like, right there, anybody want to guess what the coordinates of this point are?
3, 0, 0.
You got it. Ding, ding, ding. Okay, because the x-axis, the x-coordinate comes first. So 3, and it's not anywhere to the right or left, so it's 0, and it's not up or down, so it's 3, 0, 0. So if I go on the y-axis and put one right there, that would be 0, 1, 0. Or if I go on the z-axis, that would be 0, 0, 4. So it gets trickier when you like try to float it off the axis. So you kind of go something like this, and then it goes down and hits there. So can you guys tell where that's at? Okay, it's supposed to be directly above this. I kind of missed, but so the coordinates would be 3. Is it going any to the right any? No. So it's 3, 0, 4. So it's 3 forward, 0 to the right, and 4 up. Like the rain.
You should just go home and enjoy this rainy day.
You can enjoy it right here. Okay, let's do like one more of these here. About that point, where is that at? Okay, it's 3, 3, and 0. 3 forward, 3 to the right, because it matches there, and 0 up. we'll do this and then we'll get going. So let's say that's on that mark and that's on that mark. I didn't draw this great, but I'll just go ahead and put that there. Alright, let's do all these points and we'll get going here. What's the coordinates for, here, let's go around the room, shall we? Do anybody want to volunteer to start? Okay. Sam, what's the coordinates for this point going to be?
5, 0, 0.
5 forward, 0 right, 0. Okay, Leo, how about this one?
0, 6, 0.
Yep. 0 forward, 6 to the right, and 0 up. Okay, Allison, how about that one?
Now that it's a cube, it's confusing.
Okay, so is it any in this direction?
No.
No.
Oh, wait. Okay, so 0. Wait.
Then this one, is it any?
Oh. 0, 5?
Yep.
Okay.
Okay. Ava, how about this guy right here?
5.
I should have made these different. Here, let's, I know this will screw up our drawing here. Let's change that one to a 4 so all the numbers are different. There. Alright. Yes, 5, 0. Yeah. 5 forward, 0 to the right, 4 up. Lydia, let's do, how about this one, Lydia?
0.
Yep.
4, 5, 4, 6.
Okay, next one is the Y, so the 6 comes next, and then the 4. Okay, let's see, Katie, we got left. We're almost done here. I guess Sebastian gets, how about, Katie, how about that one?
5, 6, 0.
5, 6, and 0. Sebastian?
0
Hmm?
and 5.
Yeah, so how far this way? Yeah, it's coming 5, okay. No, I'm gonna squeeze that in there. Is it going this way, Annie?
Yes. So 6. And then 4.
Yeah, you gotta use your 3D imagination. It's coming out, it's going to the right, and it's going up to get there. You kind of have to like travel along this path, you know, to get there. All right. So what would this point right here be?
0, 0, 0.
0, 0, 0. Origin. Okay. Let's jump in, shall we? I'm on the wrong page. 5, 450. Oh, okay. Do you guys remember the midpoint and distance formulas? Midpoint formula for 2 points on a graph?
X minus x over 2, y minus y over 2.
Close. You average the x coordinates, so it's x plus x over 2 and y plus y over 2. So guess how we're going to find the midpoint on a 3D graph?
You also do z plus z.
You also do z, yeah. It's not really hard. So we're going to have to do this a couple times. Z plus z over 2. Okay, do you guys remember the distance formula? This one's a little bit harder.
Is this the...
X minus x squared plus y minus y squared. And you do the square root of that. So if we're doing distance in 3D, And that's what we're doing on 1 and 4, 1 through 4. 5 and 6 are more like what we're doing at the beginning. Okay. So on 1, we want to find the midpoint of 2, 5, negative 3, and 0, 3, 1. And just simplify that. So add the x's, divide by 2. Add the y's, divide by 2. 5 plus 3 is 8, divide by 2 is 4. Negative 3 plus 1 is negative 2, divide by 2.
We have to find the length too.
Oh yeah, sorry. I forgot the length. My bad. Okay. So this time it's x minus x squared plus y minus y squared plus z minus z squared. That one calculator might help there. It's just 2 squared and 2 squared and 4 squared. Yeah, not that hard. All right, 3, I'm gonna repeat the process. So, to find the midpoint, going to add the x values together, divide by 2, and the y values together, divide by 2, add the z values together, divide by 2, 2 divided by 2, negative 4 divided by 2, 2 divided by 2. And for the distance, x minus x. So you gotta be a little bit careful when you're subtracting negatives, right? That actually makes it a plus. 3 minus negative 1 is like plus 1. People get those wrong a lot. Four squared is 16. Negative 6 squared is 36. 2 squared is 4. 56. Which is 4 times 14. 2 squared, 14.
Hey Leo, do you have one of those like eraser thingies? Let me check. No,
How was your guys' VOM experience yesterday?
it was great.
What'd you do?
Put stickers on books. It's very relaxing for no reason
Yeah,
at
it's
all.
really
You were fast.
I mean, you're putting stickers on stuff, so I believe in you guys. I think you're up to the challenge.
I think we're crazy.
What'd you do?
He was just really fast.
Oh.
Like by the time I did like 2, he had already done 5.
He was like a sweatshop worker.
He was
Okay. Oh, dang it. I need that picture. I'll just go back and cheat and use it. Okay, they drew this picture on 449. So you're supposed to kind of refer to that.
You used the exact same.
Did I use the same?
Yeah, you used the exact same numbers.
Yeah. Maybe it was in my subconscious.
Means we already know all the points are.
Yeah, so we actually already did number 5 accidentally.
Do we need to write it down?
Yeah, let's use some points for it. So, let's see. This was A, B, C, D, E, F, G. It goes A, B, C, D, E. Did they ask for all those points? Find, yeah, vector OG. OG. Classic. Alright, yeah. So those are all the answers. But how do we find, we didn't do this, how do we find vector OG?
Would be the 2 points at O and G.
Or sorry, the magnitude of vector OG,
Oh, okay.
that's what they're asking for. The vector OG would just be 5, 6, 4. I mean, it's just going from 0, 0, 0 to 5, 6, 4. But how do we find the magnitude? What does magnitude mean? What's that mean when they put those lines like that? And magnitude means the length. There you go. So how are we going to find the length from O is stands for the origin, from O to G? The distance formula. But since we're starting from the origin 0, 0, 0, it would be like 5 minus 0 squared, 6 minus 0 squared, 4 minus 0 squared. So, I'll go ahead and write it, I guess. So it's basically just 6 squared plus 5 squared plus 4 squared and the square root of that. 36 plus 25 is 61 plus 16 is 77. So it would be square root of 77. Does not simplify. Yeah, okay. 7 is kind of easy peasy.
Sweet. Plus.
3, negative 2. So they wrote like this, but I think we're supposed to think of these as vectors, but it doesn't really matter. It's just like the vector work we were doing on the 2D version. So you just multiply this vector by 2, and then add it to that vector. So 4 times 2 is 8, plus 3 is 11, Negative 1 times 2 is negative 2 plus 8, 6. 2 times 2 is 4 plus negative 2 is 2. So anyway, I just multiplied these by 2 and added them to the other vector. Easy peasy. B, this goes back to yesterday. They put like a dot, like a time symbol in between. What does that mean?
You multiply the x's, y's and the
Right.
z's.
X times X plus Y times Y plus Z times Z. 5, 2, 1. It's the dot product is what they called it. So X times X plus Y times Y plus Z times Z.
Oh,
Hmm?
I did that different.
Alright, so 5 plus negative 16 is negative 11 plus 6 is negative
I
5.
didn't add the different.
Okay, you have to add between. And then C says the magnitude of a 351.
That's where you square.
Yeah, so it's kind of like the distance formula. It's just 3 squared. Remember when we did, or maybe you don't remember because it seemed like every time I asked we didn't know. How did we find the magnitude of like a 2, negative 3 vector? We just did that squared plus that squared and then took the square root of it. So same thing. 3 squared plus 5 squared plus 1 squared, and then you do the square root of that. Kind of like the Pythagorean theorem, but it's in 3D. It still works evidently. 9 plus 25 is 34, 35. Okay, on number 9, you guys might have forgot this. We did like one of these problems a couple days ago. How can we use the dot product to tell whether two vectors are perpendicular? If you do the dot product and it comes out as 0, then it's a yes, they are perpendicular. If otherwise, it's a no. 6, 3, 3. So basically, we just gotta do the dot product again. 3 times 6 plus negative 7 times 3 plus 1 times 3. 18 minus 21 is negative 3 plus 3 is 0. So we're supposed to put yes, they are perpendicular. So on 10, they want you to choose K to make them perpendicular, so you just act like you're doing the dot product, set it equal to 0, and solve for K.
Seems like school closing rain.
Do you melt in the rain? Wicked Witch of the West.
Yes.
We could turn this hill into a really cool slip and slide.
That'd be so much fun. They've done that before. Someone like broke their arm.
That sounds about right.
What?
Small price to pay. tree.
I mean, you could like link together a bunch of slip and slides and like go down this curve out here.
It get much into the highway. Even better.
You could go around this like loop and like build up a little wall so that you like curve.
Yeah, you'd have to make a, sidewalk.
like grass hill.
It'd be like luge from the Winter Olympics. Huh?
Like grass hill by the church that goes down.
Yeah.
Well, Nathan set up a giant slip and slide. And the kids fell down and went off and hit a tree. He broke his arm.
Well, she was not, that was like her shell shockers.
How do you hit the tree though?
Yeah.
I don't know.
Do you remember when we watched the Indian men building in history?
Yeah.
For like a week stream.
What?
Yeah, you know those people on YouTube where they build like the underground things? We
Yeah.
begged Mr. Frederick to
You
let
made
us
a
watch
doghouse.
that.
Yeah.
I was so sad when I learned it was fake. I was like,
It's fake.
They're
yeah,
not
they use
They're real.
no, they
They're
don't.
real.
They use actual like
No, they don't.
construction equipment and then just.
They show the whole thing.
Yeah, well, I literally watch all of
What
it.
they want you to think like.
It's uncut. There's no
Yeah.
cuts in there.
Yeah. It's all real, so,
They just happen to have cameras.
yeah. It's crazy.
And the, wow, and remember the one with the puppy dogs?
Okay. Alright, I'm guessing you guys forgot this too. They're talking about spheres a little bit. Do you guys remember on a normal graph what shape this makes? X squared plus y squared equals 9. Makes a circle with radius 3. And if you do this, like, so this would be a circle, but it moves right 3, down 2. So the center of this circle would be a positive 3, negative 2, and the radius of the circle would be 5. Okay, so the same rules apply in 3D with a sphere. So the equation looks almost the same. So on 11 they want, if the origin is the center for A, so you just do x squared plus y squared plus z squared. What was that noise? Containing the snot. Okay, and the radius is 2. So if the radius is 2, then this number out here needs to be 2 squared. So it's 4. Oh, wow. Okay,
Like that's the answer.
for A, yeah. For B, it says the center needs to be at 3, negative 1, 2. So how are we going to remove this 3 in the x direction?
X minus 3.
X minus 3. And then how are we going to move it negative 1 in the y direction? Y plus 1. Yeah, you just do the opposite. Yeah, I'm just going to erase this. Hopefully you don't need that anymore. And then 2 in the z direction.
Minus 2.
Okay, and I guess the radius is still 2, so this number out here needs to be 2 squared. So. See? Easy peasy.
What about when it says like radius is 7? Do you put 49?
Yeah. So, how can I tell if like this point 3, 2, 1 would be on the sphere or not? Would- Okay, all the points that satisfy this equation, I can't really draw a sphere, will be on the sphere inside that 3D, you know, whatever. If you plug these in, 3, 2, and 1, and it equals 4, then it's a point on the sphere. That's how you know. Kind of like when you plug in like 2, 1 into a linear equation, it should be a point on the line, if it works. Okay, anyways, I'll help you guys with 12, because you're not going to know what to do. 12.
That's not true.
Find equation of the sphere with, okay, the first part you should know. Actually, I just said the second part, so I'm not going to do it. The second part is 7, 7, 6 going to be on the sphere. So all you do is you plug 7, 7, and 6 in, and if it works in the equation, then yes, it is a point on the sphere. But you first need to find the equation for the sphere, so it's going to look like 11b.